All right. So, how are we doing? We are doing well. Yes, we are. Okay, good. So, what we're going to do is we are going to talk about the abacus. And I'm not sure if you've seen my post. It's been up there, kind of. Okay, so we're going to count 1, 2, 3, 4. This is 4. So, when we look, these are the horizontal bar. The horizontal bar is what's being counted. Why are we doing this? We're doing this because we're learning how to read the abacus and we're doing math. We're doing math. If you're welcome to join math if you want to learn more about math. So what we're going to do is we're going to do 1, 2, 3, 4. That is the bead. This is the horizontal bar. This is the beads. These are the beads. And so what we're going to do is we're going to read 1, 2, 3, 4. This is 4. This is 5. The top bead will always be 5, no matter what. The top bead will always be 5. So when we look, we have 5 and then 6. After 6, we have 7 and then 8 and then 9. So then somebody was like, I don't get it. I still don't get it. I was like, huh, okay. So this is 1. When we look, this is 1. This is 2. When we have 2, 1, 2, then we have 3. 1, 2, 3. And then this is 4. 1, 2, 3, 4. Maybe I got to talk slower. Maybe I talk too fast, right? So we have 4. Anytime the beads are touching this horizontal bar, this is being counted. This is what we call 4. How do I know? Well, when we look, when all the 4 bottom beads touch the beam, this is counted. These beads are counted. So if you notice, none of these beads are being counted. So because none of these beads are touching this horizontal bar, they're not being counted. So these are all zeros. However, this one is counted. This one is a 0. So when we look, we have 4. 1, 2, 3, 4. And then we have 5. The top B will always be 5. Oh, that's not 5. Well, we have to show this is 5. 5. There we go. 5. So when we look, this is 5. We have 5 and then 6. After 6, we have 7. Then there's 8 and then there's 9. So when we look, we have 9. However, when we do this, this is now 0. Because this is 0, we have 1, 2, 3, 4, 5. And then we have 6, 7, 8, 9. Okay. How are we doing? Anybody have any questions? So then this is 10. Well, how do I know that's 10? Well, this looks very familiar, doesn't it? So this is 1, and then this is 10. Now we're talking about place values. We're talking about place values. I got to find my little thingy, my little label thingy. There we go. Oh, there we go. Even better. So we know how to read, right? We know how to read in abacus. I'm sorry, we know how to read our numbers. We have our ones, our tens, our hundreds, our thousands, our 10,000. When I line it up, just like that, I line it up. This is our ones, our tens, our thousands, our hundreds, our thousands, our 10,000. So now it's easier to understand. Yeah? Yeah? Okay, good. So what we're gonna do is connecting to the to go live. Oh, that's not working. Okay, we have 1, 2, 3, 4, and then we have 5, 6, 7, 8, 9. The top bead will always be 5, no matter what. Anybody have any questions? Anybody have any questions? So what we're doing is we are reading the abacus. So before we go into adding, subtracting, multiplication, division, we're going to learn how to read the abacus. And so when we do this, we have 10, 20, 30, 40, and then 50. 50, 60, 70, 80, 90. So when we look, this is 80, this is 70, this is 60, and this is 50. How do I know that's 50? Well, I have my ones. This is my ones. This is my tens. This is my tens. And these are the hundreds, the thousands, and the 10,000s. Anybody have any questions? Let me know. Thank you for the heart. Thank you for the heart. Let me know if you have any questions. But now we're reading the abacus. So if I did this, what number in the comment? What number do you think this is? Hey, Audrey. Welcome, Audrey. It's so lonely. Everybody's like coming out. Hey, Dexter. Almost, Dexter. Almost. Thank you, Pancake. Yes. So this is 5. This is 6. This is 7. The top bead will always be 5. This is 6 and this is 7. The bottom bead is a value of 1. There's a top bead, a value of 5. So when we look, this is 9. I thought you guys were not around. So When we look, we can do 19, 5, 6, 7, 8, 9. And then we have this. This would be 19. This is 9. I'm sorry. This is 9. And we could do 19. We could do 29. After 29, we could do 39. Thank you, Pancake and Dexter, for the follow. So when we look, if I did this number, what number do we think that is? What number do we think that is? I guess I didn't copy it. Edit. What number do we think that is? Oh, I have to remove it. Ugh. Ugh. Whew. 18. Yes, you guys are right. It is 18. Hello, Bunny. Hello, Pancake. Yes. Wow, I never thought I'd learn this on TikTok. Ha! Dexter. Well, good. I don't know if that's a good thing or a bad thing. I've got some hate. I had some hate comments in my last post. Oh, I made it. Anyways, so this is 20. How do I know this is 20? Because I have my ones, my tens, my hundreds, my thousands, my 10,000. So when we look, just as I did this, this would be 520. So then 58. Oh, 58. Very close, very close. 50 is this. This is 50. And then this is 8. 5, 6, 7, 8. So now, if you understand, this is 58. So I'm going to write it because sometimes it's easier to see how it's being written. So 58. We have our ones, 5, 6, 7, 8. Thank you, Pancake. This is so helpful. I'm so happy. Thank you for the share. This is 5, and then we have 50. So we have our tens. This is 50, and then this is 8. Does that make sense, Ree? I hope so. Let me know. Why, Atticus? It's been so long. I haven't seen you for so long. I thought you were over and done. I'm done. She's talked about me so much. All right, cool. Yes, I am. I even made a post and it's almost like 1 million views. And I did it like on Wednesday. And I'm like, holy crap! People, but it's all being served to like young kids. And they're like, what is this? Uh, uh, all right. So, what are we doing? We are still reading the abacus. When we read it, we go, why? You're such a nice lady. People don't like my posts. Okay, so we're going to continue to count. When I do this, right? What number, and I do this, and then I do that. What number do we think this is? What number do we think this is? Okay. Hey, Kaya? Kaya. There we go. Yes. Thank you, Super Mage. Yes, 50. No, not 56. Some dude. Hey, some dude. No, it's not 50, 61. It's 5. It's 900. 900. Because it's 5, 6, 7, 8, 9. And then this is 60, 5, 6. And then this is 1. So it's 961. Oh, so I think we're ready for some more bead recognition. This is a little book. Here's my little book. I'm very happy you guys are catching on. So here's a little book if you guys want to. There is this book that I created, and this is all about how to read the maze, how to read the abacus in a maze form. So the first thing we're going to do is we're going to understand that we're going to start here. And after we start, then we're going to go all the way all here, and then we're going to try to figure out how to get to the path that says finish. Yep. So if I do this, what number do you think that is? Wow, 52. What? Already? Oh, Kaya, you're so good. You're so good. So we do that. We do this. We do 50. We do 2. Now, if you look, there's a 5 up here, and there's 2 here. Okay, you know what? I think Kaya's seen this one before. I'm going to change it. You know what? Just in case, let's do a different one. All right. There we go. Let's do something different. We'll do B. You guys have to keep track of the ones that we've done. Okay. Let's try. Oh, no, that's not start. Where's start? Start's right here. There we go. All right. There we go. Atticus. Okay. We're doing this. There we go. How about that? There we go. Sorry. You guys are so fast. Okay. That's what? 60, and this is 1. All right. Oh, that's not 1. This is 1. Yes. 61. 1, 5, and a 6. And then this is 1. So we're at 61. And then we need to go this way, and now we're here. What number do we think this is? Yes, Pancake, 61. Wow. Kaya's really going. 30, right? We have 30 and then 9. 5, 6, 7, 8, 9. Thank you, Dexter. Thank you for the share, buddy. Thank you, Lolo. LOL. This is so easy. It is easy. It is easy. I'm telling you. Abacus is simple to use, easy to understand. Simple to use, easy to understand. Oh, that you guys can't see that one. There we go. There we go. Yeah, Kaya's like super fast. I'm telling you. Okay, let me see. How's that? 50. Ooh, Dexter. I think that was a typo. Because it's 50. LOL. CBT. 50 and then that one. Yeah, there we go. Yep. Thank you for the follow. Eyes. Yes, I know. Typos. It happens. It happens. All right. Oh, Kaya, where are you? Thank you for the share. Thank you for the share. But where is Kaya? 60? Pancake says 64. Oh, for some reason it works in my head. For some reason this really works in my head. That's fantastic, right? That is fantastic. LOL. Yes, 64. So it is 60, right? 4. You know why? Because it's visual. It's very visual. My bad. Yeah, I got it. Yeah, right? I'm telling you. But see, that's the thing. Like, nobody has really told you how to read the abacus. I'm going to tell you all the secrets to abacus, and then you'll see my magic. So we know this number. We've done that one. Yep. That was easy, right? This one's easy too. Why is this easy? That one's easy. What grade do you learn this? Haha. I'm trying to teach everybody. I started when I was like super old. And then 99, right? 99. That's too easy, right? I usually start the kids. I would like to start the kids as early as 3 to 4 years old. It is 99. And but a lot of the abacus curriculum starts the kid at age 5. They usually go by ages, they don't go by grades. And so what I'm trying to do is I'm trying to create a curriculum that is more grade specific. Thank you for the follow, KK. Woo! Yeah, 91. And so, because I've been doing lives, I've been inspired more, and I realized that what I need to do is have more grade specific abacus. But because I have to do grade specific abacus, I have to really curate those numbers, those questions, because every question is very different. 60, 70, 70. Yes, 75. Yes, thank you. Thank you. 75. Wow. All right. 7, 5, 6, 7. And then this is 5. So notice the top bead will always be 5. The value of 5 will always be the top bead. Just so you guys, whoever's coming in, I just want to make sure that they understand. Learning. Yeah, right? That's the funny thing. You guys are in the middle of the night learning math. You guys are voluntarily being here to learn math, which I think is hilarious. Whew. All right. So we have this. Yes. We have this, and then we have that. So we have this number 5. 1, 2, 3, 4. Dexter, did I answer your question? I don't know if I answered your question. I hope I did. So yes, this is 54. We have 54. Pancake's killing it. Yeah. Okay, good. And then we have this, and we have that. What number do we know? We know that is. It's 5. It's 120. Woo! Yeah, see, that's what I'm saying. You guys are learning math in the middle of the night. That's like crazy. You guys are nuts being here. But I do appreciate it. I do appreciate the nutsness. But I didn't think anybody would be here, and I'm just kind of like here, counted. So we have that number, we have this number, and then we have this number 5, 6, 7, 8. 5, 6, 7, 8. But after this, thank you, pulling an all nighter to learn math, right, Pancake? That's what I'm saying. I don't know. You guys are nuts. Okay, finally, last one. What's the last one? Because after this, we're going to start learning how to move the beads. Okay, this is the last one. What's the last one? And the answer is to the universe. This is the answer to the universe. I don't know if anybody's read The Hitchhiker's Guide to the Galaxy, but that's the answer to the universe. 42. 4, 1, 2, 3, 4, and then 2. And then I do a lot of like, yes. either you are old like me, or or you read old people stuff. All right. So this is available if you guys are interested. It is available here. I have it on my website as a printable. If you want the book, it is available here, and I'm going to try to put it on my TikTok shop. I just haven't done it yet, but it's going to be there. And before I forget, and then there's this other one called I call this a reverse maze. And so this is a reverse maze, and this reverse maze is interesting. So I give you a what do you call this? A template of the abacus. And so what you're trying to do is I give you the path. And so what you're trying to do is you're trying to mark the number. There we go. We're trying to mark the number. So I'm going to take the 60, I'm going to make it 68. So I do 5 and then 6 and then 5, 6, 7, 8. And then I go to this box right here. And then this box, I know I have to go here to get to this box, right? So 24, 20, and then 4. 1, 2, 3, 4. And then I come down to this box. So this is what I call a reverse maze. And so then here I take this 70, 67, and I do 60, and I do 7, 5, 6, 7. Yeah. What is the name of the book? The Hitchhiker's Guide to the Galaxy. Hitchhiker's Guide to the Galaxy. Oh, that's so neat. Yeah. Let me see if I can. Let me see. I have a question. Yes. Pancake. What is your Hitchhiker's Guide to the Galaxy? Yes. What is your question, Pancake? Um, on the reverse maze, why is there two beats? You know what? It was a little bit of a typo, and actually, what I did is I modified it so you only get this top and the bottom. So I did modify that. This one is a typo, so I updated it. Yep, that's a good catch, though. That's a very good catch. When somebody else saw that too, and it was just like, oh, so I was going to remove it because I do realize it's extra and it's not needed. Yeah, it's not needed. The two top beads and the two bottom beads are not needed. Yep. Thank you for your question. No, that is makes good sense. Yeah. And so I was like I was actually kind of being lazy, but then I realized it causes too much confusion. So I went back and I updated it. So if you were to buy it now on Amazon, it's updated. I have to check on my website if I updated it. Okay. So that is that. Would you bring the top beads down for the 10? Yes. So that is what we call a Chinese abacus, which is different than what I'm teaching. So in a Chinese, excuse me, in a Chinese abacus, it still works. It's very similar. 1, 2, 3, 4, 5. This is 5. Then we would trade it in 5 and 5, and then we count 6, 7, 8, 9, 10. So we trade this in to the top beat. So this would still be 10. Because this is 10, we would trade this in and we would do that. So this would be 10 because it's the ones, the tens, the hundreds, the thousand. It still works the same. It's just now you can do like 15 here. When we look, we can do, right? So how would you do 15? Oh, I could do this 15. I could do this is 15, or I could do this is 15, or I could do this is 15. So there's many ways to do 15. It just depends on how you're working on how you work the abacus. In the Japanese abacus, 15 would look like this: 1 and 5, and that would be the only way to do 15 on the Japanese abacus. Yeah, so it's interesting. It's pretty versatile. But it is a little, I find it is a little redundant in some aspects. Other aspects is pretty quite interesting. But this is the Chinese abacus, and then this is the Japanese abacus. The Chinese abacus was before the Japanese abacus, and then the Japanese made it more efficient. Yeah, wow! I love this. I've always been curious. Oh yeah, I'm a big hitchhiker thinking those were stacks of potatoes. Yeah, they are donuts. Yeah, could you do multiplication on it? Yeah. I think the Chinese one look easier. Um, yeah, some people do like it. So we could do times table on this one. So 6 times 6, 6 times 1 is 6, 6 times 2 is 12, 10, 11, 12. And then I'm going to trade this in. I go that's 12. 6 times 3 is 18, 1, 8, 5, 6, 7, 8. 6 times 3, 4 is 24. I'm going to trade this in, and I do that. So now we have 24. 6 times 5? Where are we? 6 times 4, 6 times 4, 6 times 5 is 30. So this is 30. 5, 6, 5, 6, 7, 8, 9, 10. So this would be 30. So that's a little bit about multiplication. However, I don't do it. I don't do multiplication on this abacus. In the Japanese abacus, you have to memorize your multiplication. We can do multiplication. It's easier to do multiplication actually. I've always been curious. Big donuts. Yep, yep. Is so the abacus is modified version. Yes, the abacus one is the modified version of it. Yes, and you could do it, and it is confusing. And what about division? Yeah, we can do division. We can get to division in a little bit. But the first thing we're going to do is we're going to understand how to read the abacus, and we're going to learn how to move the beads, because what is division and multiplication? It's just fast addition and subtraction. So the biggest thing is to understand how to move the beads. Now, I don't know if anybody sees it, but you'll see that there's a ridge. There's like edges on the beads. And notice I only use the very edge of the beads to move. And so when you move it, this is a standard size abacus. So no matter how big your fingers are, you should be able to move them. Now, if you notice, when I work with the abacus, I hold the abacus with my left hand so then it doesn't move, because it's very easy to move. So if you notice, and if you have a question like this, and you need to do some you have to add a bottom bead, don't flick too hard, because if you flick too hard, then you mess up your answer. So that's the first thing about understanding how do you move the abacus. It's very delicate. It's gentle. That's what it is. It's gentle moving. You gently move the beads, right? It's not like this, like it's not like abruptly. So that's about moving the beads. Now, what we're going to do is we are going to learn how to add while we learn how to move the beads. So the biggest thing is to early understand is how to move the beads. We did some bead recognition. That's what we did here. This is a preschool book that I'm trying to gear towards like three and four. But the first thing we're going to do is we're going to understand how to move the beads. Now, if you notice that in the abacus world, what we do is we focus on the add-in. We don't focus on the result. So when we focus on the add-in, it's going to be like, how do you move the one? When we move the one, right, we have 5, and then we want to add the 1. When we add the 1, again, it's only the top bead, but I'm only touching the edge of the bead, and I go to the top bead. So now my answer is 6. Does that make sense? So when we look, right, we have 6, and then I want to add 7. I want to add 1. I'm just going to move the top bead. We're only moving the 1 bead. So the idea of adding and subtracting is making sure, do we have enough? Yes, we do. Can we do it? Yes, we can. Oh, that sounds like Bob the Builder. So when we look, we have 2. And when we have 2, it's again the same thing. We have 5. We have add 5 here. And then we add 2. Can we do it? Yes, we can. And we add 2. So notice, right? Notice that I'm adding the 2 beads. I added two beads, and my answer is 7. So when we do it, we have 6, right? We have 6. And then my question is 2. Can I do it? Yes, I can. I'm going to add 2. I've seen a video on TikTok about how it seemed hard, but now it's easy. What if you can do it? See, pancake. That's a good question. Let me finish my thought, and then we will go into, after we know how to do all of this, and then we'll go into how to do it when we can't do it. And that's exactly what it is, right? Because what we're trying to do is we're trying to critically think, what do we do when we can't do, what do we do when we are unable to do it? So I'm going to skip ahead to the 6. When I add the 6, I'm going to do 1, and then plus 6 is moving these 2 beads. We're adding the 6. Notice when I subtract, I'm moving it away from the horizontal bar. When I have it to the horizontal bar, I'm adding. When I add subtracting and I take it away from the horizontal bar, right, now I'm subtracting. So what we do is we understand easily subtraction. And I know in school it's one of those things, like concepts that kids don't understand, but in the abacus world, we can see what we're doing. So if we want to minus, I'm going to minus the 1. I just move it away from the horizontal bar. When I have it to the horizontal bar, I'm adding to the horizontal bar. I'm adding. I'm adding my numbers. Does that make sense? So it's all about the direction, and also pay attention, to attention to detail, because that means, right, that we can see that the top bead is touching the horizontal bar. That means this is being counted, and that's one of the things that sometimes the kids don't see. So if I did this, right, they're going to think it's 444, but it's not. It's 449. I hope to homeschool, and I like this more than the math I've learned. Yeah, I like this too. I was really surprised on how easy abacus makes math. And we don't learn doubles, which is what I'm going to go into. So again, minus the 5. Again, what we're doing is we're focusing on the add-in, not the result. The reason why is because in abacus world, we do more than just 2 add-ins. So we have 7. I add 7, and then I add 1, and then I take away the 5. And notice when I take away the 5, I'm going to move it away from the horizontal bar. So the top bead, we want to move it away. How do you do it on your fingers? I don't. I know there's kids that do this, and it's because they're moving these, and they can see the abacus in their brain, if that makes sense. But usually it's because they can imagine it in their brain, but I don't. But you can. I know there's a thing called abacus, a finger abacus, and I don't know how. I'm thinking that this. They said that this is 5, and these are 4. These are ones. So if you do this, this is 6. This is, and you do this, this is 7. I'm thinking. I don't know. Yes, it's those videos I've seen on TikTok. Yeah. So when the kids do this, it's because they can imagine the abacus in their brain. So we have 6, 7, and 8. And obviously 8 is, we add the 8 and we take away the 8, right? So what we're doing is we're making sure we understand how to move the beads. 8 and minus 8. Make sense? Okay, that makes it so easy instead of trying to actually, yeah, that's the difference, because what are we trying to do is we're trying to put these abstract numbers in our head, whereas the abacus tracks your numbers for you. So, yeah. Okay, so that was moving the beads. After moving the beads, we've done our, again, if anybody wants it, I do have these books available here. My name is Lynette. Welcome. My name is Lynette Young. I'm happy here to share abacus knowledge with everybody. I've been teaching abacus for about more than 20 years. Is there a reason you're doing it in the third column? Oh, that's a good question. Yes, there is a reason. So if you notice, I have a dot indicator right here. Oh, see you later, Kaya. Hello, Emily. What's the limitations of the abacus? Dexter. Oh, wait, I'm sorry. Um, Third column. The reason why is because I have the ones over here. So this is the ones, and I labeled the ones indicator. And notice these are a group of 3. So this is the ones, the tens, the hundreds, the thousands, the 10,000. If you wanted to, I could start here, but then I'd move everything over. And then what would happen is I wouldn't have any hundreds. So when I look, I can do this, and then I just have all these as my decimals. And notice if I go back to here, this is my ones indicator. I have my decimal that sits between the ones and the tenths. That is where the decimals come in. So when we have our decimals, we have our ones, our tenths, and our hundredths. Now, if you look, this is a 7-column abacus. This is a, this is a 13-column abacus. Here we go. This is a 13-column abacus. Then I sell both of these on the TikTok shop. And again, if you notice, I have the dot indicator. There's an indicator for each one of them. There's one here, one here, one here, one here. So, yeah. Well, you can't see it because it's on the video, right? Holy moly, it's a lot of, okay. Pancake. Since on the other one you had it on the edge. Yeah. So, yeah. So this one, if you notice, the reason why they have it over here is because then you can use it for money, right? So you can have it like, change. And so we can do our ones, our tens, I'm sorry, ones, thousands, millions, and billions. So when we look, we could talk about $1, $2.50. So you can actually use money. You can try to use money for this. If I start here, you could start here or you could start here. It doesn't really matter where you start, as long as you choose one, like a Pokemon. As long as you choose one. So can you show 100? Yeah. So 100, 5, 3, 1. That's that one. And then this one. Hold on, Dexter. 1, 5, 3, 1. Yeah. What is the usefulness of an abacus? A usefulness of an abacus is to help keep track of all your numbers. So you actually do the calculations in your head, and it makes it a lot easier. So you could do adding, subtracting, multiplication, division. The other thing about the usefulness of the abacus is that it provides critical thinking. So when you start looking at things, you can actually critically think, and it provides confidence to the kids. Because every time that they see the abacus, they know what the numbers are. And the problem is what? Some of the kids don't understand their place values. Whereas on the abacus, you see the place values. It's right there. We can count by tens, 10, 20, 30, 40, and then 50, 60, 70, 80, 90. So the abacus is a concrete physical thing that helps us visualize what we're trying to do. However, I know we try to do in mainstream math, we try to do a lot of things on paper. However, can you do 15 9? Yeah, 15 9. 15, 15 9, 90. Yeah. And so for this one, right? Um what I'm thinking. Oh, so it'd be also along the lines of brain gymnastics. And so when you're thinking about it, it could be like doing a Sudoku, crossword puzzles, word searches, and now I'm trying to bring in abacus. And then the other thing is to understand that I don't know why we're trying to push the kids to do everything in mental math, whereas I write like a task list, you know? When we do a to-do list, do you keep it in your head? No, they always tell you to write it out, right? And so, oh, thank you so much for the flower heart head. Flower head? So that's the other thing, right? Like I don't understand why we're always pushing the kids to do the in your head. Whereas when you start working it with the abacus, it starts to come. We learn it. I just learned this terminology. We learn it ex- explicitly. So we learn it. We're physically learning this. But then after you get to know it, after you understand it, you're going to be able to do it. You're going to be able to do it easily. So I'll be able to just go through it, and you'll be able, and you'll be able to like move the numbers. So what are we doing? Oh, so what happens? The question Pancake had asked: what happens when there's not enough? What happens when there's not enough? This is when we start talking about these questions. So what does that mean? There's these what do you call it, math facts, fact families. They call them fact families. I think they call them fact families in mainstream math, and we're teaching the kids how to make a five. That's great. Great, it's fantastic. Why? Because we utilize this in abacus world. We actually utilize this, and we make it one step further. We make it one step more. So we don't memorize doubles. Just so you know, we don't memorize the strategies of doubles. We don't memorize doubles plus one, whatever. What we do memorize is this concept. This is a fundamental concept. Why? Because if you notice, I have this five that I can utilize. I don't want any of my numbers to be freeloaders. There's no freeloading numbers here. So my question will be, let's do two. Let's do two plus four. That's easy. Yes, it is easy, but it's the concept to understand why it is easy. And so what we're trying to do is we're going to add the two. When we add the two and I want to add the four, what? There's no more beads to add the two. So because I have this concept, four plus one is equal to five. This is the five that we're going to utilize. So what does that mean? That means that I'm going to utilize this five. If we were to write it out, no, not if, when we write it out, 4 is equal to 5. This is too much. So what we need to do is we need to minus the 1. Now I have now my equation is balanced. So I have directions. I'm going to add the 5, but that's too much. I need to take away the 1. So my final answer is 6. So what did I do? I isolated this variable. I isolated this variable. This is a algebra terminology, right? I isolated the variable. It looks very familiar, right? It looks very similar to this. And so what I do, I isolated the variable. I moved the one to this side. And then what did I do? I substituted this information into the 4. So now what I did was now I have this concept of how to add a 4. Let's do it again. Let's do 3. And notice the reason why we add 3 and I want to add the 4, I don't have enough. So now it goes back to, do you have enough? No, I don't. So what do? I use this concept that I just learned. I want to add the 5 and I take away the 1. So now if you notice, this is a number pattern. The number pattern that you add, right? You add the 5 and you take away the 1. And this is the number pattern. When we add the 4, then that's what we have. So my final answer is 7. Let her. Yeah. Hold on, Yandel. What age would be best to introduce this? Cook. Thank you, Terry. Scarlett, if you're looking for something, this is what the preschool was, and I was trying to get it to be 3 years old. 3 years old, 4 years old. You could start them at when they're age of 5 if they already know their numbers. You could do that too. I do have some people that are interested. There's some of the children that are interested about 9 and 10. It gets a little hairy about 11 and older because they have too much homework. And so something just clicked. So um you could introduce it at 11 and 12 and older. It's just up to it depends if the children are open to learning something different and something um elementary kind of. So yeah, let's do one more and then Yondo, I will. My baby is loving it, so I love it. Oh, okay, yeah. So if you wanted to, I would recommend getting this one just because the color, because the abacus is it pops, the colors are nice. And so then when your baby gets older, you can graduate them to a 13 column one because you can do multiplication division on it. Okay, Yando, I don't know if Yando's still here, but we're gonna review. Let's do a little review. So we're going to review. This is 1, 2, 3, 4. These are the values of 1, and they're touching the horizontal bar. Because it's touching the horizontal bar, this is now 4. Yondo, are you still here? If not, I'm going to go continue with my adding. I need to move the class forward. Everybody wants to do multiplication division. I got lots to do. Okay, Yondo, I don't know if you're still here. If not, I'm going to go to adding and subtracting. Okay, going once, going twice. Okay, I don't think he's here. Okay, that's fine. So I'm going to continue on. When you look, we're going to do this one. Again, we don't memorize our doubles. What we memorize is the concept, right? So the question goes back to if I have 4 and I want to add another 4. The question is always, this is why we focus on the add in and not the result. We focus on the add in. The add in. How do you add this 4? How do I add the 4? To add the 4, I know this concept. This concept is plus the 5, take away the 1. I have just been given instructions how to add the 4. There's nothing else to do. I don't need to memorize. I just follow the direction. So you start to get into the part where you start to see the number patterns, right? You're going to see when we add, right? When we add the 4, you notice I want to add the 5 and minus the 1. When I subtract minus the 4, I need to minus the 5 plus the 1. When you look, this is the number pattern that we're looking at. And you'll see as we go through, you can do it for the 3, right? We can do it for the 3. These are the pairs that we can use this. And this is what we call making fives. You'll see that you'll see the pattern. You'll see the pattern because I believe in the pattern. So here's the 3. When we do the 3, let's do 3 plus 3 because that's easy. 3 plus 3. When we do 3 plus 3, I'm sorry, I need to move some stuff. When we do 3 plus 3, remember this is a very familiar. This is the same concept. So what we're doing is we're solidifying our concept. We're solidifying, compounding our math knowledge. When we do 3, remember when we do 3 and we equals to 5, it doesn't make sense. It's not balanced. Because it's not balanced, what I need to do is I need to take away the 2. Now it's balanced. What does that mean? So when I have 3, I don't have enough to add another 3, right? I only have 1 here. So to add another 3, I plus the 5 and I take away the 2. So my final answer is 6. Does that make sense? Right? So we do it again. Let's do it again. We can do it again. We'll do 4. When we do 4, right? We want to add the 3. When we add the 3, what are we going to do? We're going to plus the 5 and we take away the 2. My final answer is 7. So what did I do is I just looked at my add-in. I looked at the number that we were adding. and we were making sure that we understand how to use it. So now it becomes versatile, and now we can scale it. Does that make sense or no? Are we all right? Do we need a review? We can review. Oh, pancake. JP, not really understanding, or not really have any questions, because I know you've been here for a while. So adding two, you take away the three. Yes, the reason why is because you're utilizing this five, right? Oh, you know what? Here's another one. Here's another one. Let me. Okay. So let's say I have four. Let's say in the store I have four, right? Or is it four? Yeah. But I only have a nickel. So if I give you a nickel, I need change back. It all makes sense in the end. But it all makes sense in the end. It does take a minute, but don't forget it takes a minute because it's something brand new. So I only have a nickel. I'm gonna exchange it, right? I'm gonna add four. You have four, but I only have a nickel and it's only worth three. So I'm gonna give you my nickel. I'm gonna take two away. So my answer is seven. Does that make sense? Atrocious cookie. So, right? So yeah, it makes sense with money. So I found this and I was like, that makes a lot of sense because I give you a nickel, there's not enough. So if to do an exchange, you have to give me back two. Yeah. So the blue ones, yes, exactly, Sale. The blue ones is a value of five. Yes. The blue ones will always be a value of five no matter what. This is five. This is 55. This is 555. This is 5,555. Yep. These are fives. If you want 10, that's what 10 looks like. Right? And if you want 20, 20 looks like this. 15 looks like that. One and a five. 15, 50, because now we have 50 cents. So it's $15.50. So what did we just do? We just understood how to make a five. Are we okay with understanding how to make a five? We can do the minus five. Why do we want to minus the five? We want to minus the five. Oh, hold please. We want to minus the five. Now we're going to copy the what is it? We're going to copy the equation again, but now we're going to have the opposite. Hey KK, we're going to make the opposite operators. We got to do minus. The reason why we have to do the minus is because we want to minus the five. We want to take away the five. But we did the adding. Notice we do the adding, right? If you imagine there's a plus here, plus 3 plus 2 equals plus 5. But now what we're going to do is we're going to minus. To do the minus, it's minus 3, minus 5, minus 2, minus 5. Why do we need to know this? The reason why we need to know this is if I was to do 7 minus 3, there's a minus there. Do you see that? How do you take away the 3? Well, if you notice, when I have 7 and I need to take away the 3, there's not enough. Oh, have a good night. Welcome back. I haven't seen you in a little bit. So when you look, I want to minus the 3. I don't have enough beads to take away the 3. So what do? I go back to this concept. I go back to this formula. Hello, furious programmer. Minus the 3 is equal to minus the 5. Notice this is not balanced. It will be plus the 2. So I'm going to minus the 5. I'm going to add the 2. So my final answer is 4. Notice what I did is I just compounded our knowledge. We know how to do this. Now, what we're going to do is we're going to practice it. We're going to practice it till we understand it. Are we all right? Does that make sense? Music band. Pancake. I love Pancake's reaction. Oh, yeah. And it makes it easier, doesn't it? Doesn't it make it easier? Yeah. So, and this is and that, I mean, it's great to like talk about multiplication and division, but understanding the basics, understanding this, because when you understand this, it will be a lot easier to get into multiplication and division. Yeah, are we okay? Yeah, makes sense. Do we want to do another one? We can do another one. We can do another one. We can do 2. We have 4, and we want to add the 2. Again, I don't have enough beads. Okay, thank you. Well, okay. I don't have enough beads to add the 2. So what do? I have this concept. I know this concept. We know the pair, right? 2, 3 equals 5. 2, right? We need to isolate that variable. To isolate the variable, we do 2 is equal to 5. 5 is too much. We need to minus the 3. So because I want to add the 2, I want to plus the 5 and take away the 3. So my final answer is 6. Okay? So what are we learning? We're learning how to move the beads. We're learning what the pairs are. We're taking the idea of, what is it? These concepts that we're teaching the kids, when we're taking it once, we're leveling it up. So what we're doing is we're not memorizing our doubles. What we're doing is we're memorizing our formulas. These are formulas that we talk about. Abacus world is what we call formulas. You could call them equations, you can call them number sentences, you can call them, there's a lot of terminologies in mainstream math that I don't know. um, but here, the reason why we need to know how to add, no, the reason why we need to know how to subtract is because it's part of the system, it's part of the methodology. We can't just add without subtracting, you have to do both. It's a balance, right? Just like the left hand, right hand, left foot, right foot. If you have 2 hands and 2 arms, you know what I mean? So when you understand how to add, you need to know how to subtract. So that's why we have this. So that's why the next step is to understand how to make a 5. When we make a 5, what we're doing is we're balancing our equation. The reason why is so then we can utilize this 5. Okay. And it's the same thing if we do the minus. When we do the minus, we could do the same thing with the minus. What is it? 6. We do 6. We can do 6 minus 2. 6 minus 2. So 6 minus 2, right? And then after knowing this, it's scalable because it can be like 600. So even here, like we do 6 and we want to minus the 2. There's no more beads to minus the 2. What do I do? To minus the 2 is equal to minus the 5 plus the 3. So I'm going to minus the 5 and then plus the 3. Minus the 5 and add the 3. So my final answer is 4. Oh, here it is. 4. Yeah. So that's the first major concept that we need to do. The first major one is to understand how to add a 5. Now what we're going to do is we are going to how to make a 10. Are we ready or do we still want to do how to make a 5 more? How are we doing? How are we doing? Do we want to continue? Okay. So, pancakes ready? Okay. Everybody else, let's make it 10. Okay, cool, KK. Great. So that was one. That's the next one. So this is the next one. How to make a 10. Again, why are we doing this? Why are we learning math in the middle of the night? We're learning it because we are crazy. So we're teaching this to the kids. We're teaching how to make a 10. That's great. How does it work in the abacus world? How to make a 10. What does that mean? 10 is that. 0, 1, that's 10. So keep that in the back of your head. When we look, we'll do this one. Hey, that looks familiar. When we make a 2, these two are pairs, right? 8 and 2 is a pair. Looks very familiar, doesn't it? We've done this sort of concept before. We did 4 plus 1 is equal to 5, but now we're going to do is making a 10. So we're adding and compounding our knowledge. When we do that, we have our numbers. What is our number? There we go. So my question is 8. I'm going to add 8. No, I'm going to add 7. I add 7 to my abacus. I'm going to add my 8. Can I do it? No, I can't. I cannot be Bob right now. How do I do it? I have to be MacGyver. There you go. I have to be MacGyver. What do I do? Well, you know the concept 8 plus 2 is equal to 10. Well, what does that mean? Well, I want to add the 8. I'm going to isolate my variable. So I'm going to have 8 is equal to plus the 10 minus the 2. So what are we doing? We're going to plus the 10, 0, 1. I'm going to add 1 here, 0, 1. I'm going to add 10, and I'm going to take away 2. Is there enough to take away the 2? Yes, there is. So all I got to do is take away the 2. My final answer is, what's my final answer? 15. Yes. Easy, right? It is 15. Thank you, KK. Thank you, Pancake. Thank you, Eve. Yes. Welcome. Thank you, Sale, for the follow. Does that make sense? So let's do another one. Let's do another one. We'll do 4, right? We can do 4. When we do 4, I want to add the 8. Is there enough to add the 8 here? No. All the beads from the 4 is being done, and I only have a 5 bead. What do I do? Well, I know this concept. I know 8 plus 10 minus 2. This is exciting. Excited to learn. So we're going to plus the 10, 0, 1, 0, 1. I'm going to add the 1 over here and then take away the 2. So I'm going to take away the 2. What's my answer? What's my final answer? I'm over here. 4 plus 8. What's my final answer? 12. See, notice how what we did is we focused on our add-in. We don't need to worry about everything else. Thank you, KK. Thank you, Pancake. It all makes sense now. Yes. Yes. Thank you, Eve. Yes. So let's do another one. We'll do 9. When we do 9, it's the same thing. Can we do it? Wait, I think I get it. Yeah. Can we do it? No, we can't. What do I do? Well, we can trade our 10, right? We can do 10, right? 0, 1, 0, 1. 1 is over here. 1, 10 is too much. We're adding 10 is too much. We need to minus the 2. So my final answer is 17. Nice. Yeah. You got it, Eve? You're all right? Cool? How are we doing? More. Okay. You guys are crazy. Crazy, crazy. In the middle of the night, we're doing math. Who would have thunk it? I would have never. I would have never thunk it. Let's see. This one. Okay. Here is. You're so helpful for teaching us this. It's so fascinating. Midnight math. I'm telling you, midnight math. You guys are all midnight mathers. Okay, we're going to do this one. We're going to do 4. Oh, sorry. 4 plus 7. Oh, that's the wrong one. 4 plus 7. 7. Okay? So we had 4 on our abacus. We had 4 on the abacus. This is the question. 4. And then I'm going to add 7. When I add 7, what do I do? What's the formula for 7? Do you guys know what the formula for 7 is? If you could put in the chat, let me know how to make a 7. I want a 7 equation. The 7 formula. Yes, Eve. Yes. So what the equation is, what the formula is, 7 is equal to plus the 10 minus the 3. Yes, thank you, Pancake. Yes. So plus the 10, and I'm going to take away the 3. So my final answer is 11. What else? Oh, you know what? And then we could do these ones. We can do these ones. These ones. Yeah. So this is my other book. This book is all about making a 10. All right, we can do this one. Let's see. Trying to find what? Okay. We'll do this one. There we go. There we go. Okay. So this is very common to have more than one add-in. We have the 2. We have the 2. We're going to add 2 to the abacus. And then we have 8. What is the value? What is the formula for 8? Excuse me. What's the formula for 8? Thank you, Pancake. Plus the 10 minus the 2. And then I plus the 7. Thank you, Eve. Yes. And I plus the 7. So my final answer is 17. Yeah? Sale, does that make sense? Are you all right? What are we doing? So yeah. Yeah. So after this, what we can, oh yeah, we could do this. These are similar. Okay. We have a 9. We add the 9. We add the 1. Almost. That's okay. What is the formula for plus 1? What's the formula for plus 1? No, we want to add the 1. There's not enough beads to add the 1. So if there's not enough beads to add the 1, it's actually the other way. It's the 9. So it's going to be, yes, thank you, Eve. Yes, thank you, Kay. Yes, it's actually 9 is equal to plus the 10 minus the 1. Or it can be minus the 1 plus the 10. It can be either one. Because we're adding the 1. That's what we're trying to do. We're trying to add the 1. We're trying to add the 1 here. That's why it's minus the 9. Make sense? So when we do it, nope, 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 nope. I'm wrong. I'm wrong. I'm wrong. Sorry, sorry, sorry. Everybody else is right. I'm always used to doing the other way. 1. There we go. 1 is equal to minus the 9 plus the 10. Or plus the 10 minus the 9. Yep, yep. Sorry, my bad, my bad, my bad. Because what are we trying to do? We're trying to add the 1. We're trying to isolate the 1. So my question is 9 and I add the 1. When I add the 1, it's minus the 10, minus the 9 and then plus the 10. So I add the 10 there. And then what do I do? Plus 2. Plus 2. So my final answer is you're adding 1, not 9 in the, yeah. Yeah. Yeah, that was my bad. I was stuck on my numbers. Because I don't do 1 very often. That's why. Yeah. 12. Yes. Thank you, Kay. Yes. So then when we do it, we could do another one. Let's see. Oh, here we are. So this one is a puzzle. You answer the puzzle on the board, and then you find the answers here. So, but we can do this. The question is 6? Let's do this one. 6, right? We'll do 6. And then we plus the 9. What is the formula to plus the 9? Oh, goodness. Oh, see, this is very common. These number of add-ins is very common in Abacus world. Yes. So I have 6 and I plus the 9. Thank you, Pancake. It's plus the 10 minus the 1 because we're trying to add the 9. And then we want to take away the 2. Do you remember how to take away the 2? No, okay, it's the other one. We're trying to add the 9, not add the 1. Minus, yes, exactly. We want to add minus the 5. We want to take away the 5. We're going to take away the 5 and we're going to add the 3. So it's backwards. See, this is where, yeah, this is where knowing your formula, it really helps, right? So when we solidify this, I mean, obviously you guys just learned this, right? So I mean, you guys are doing really good, but you've just learned this. Yeah, because because it is subtraction. Yes. Exactly. When we want to subtract, we will subtract the 5. When we want to add, we will add the 5. Yes, exactly. Exactly. So here I want to add the 8. There's not enough beads to add the 8. What's my formula? What's my formula to add the 8? Am I sick? No, I get I have really bad allergies, and I get really nasty coughs. And I have the fan on because it's a little warm, and so all the dust gets picked up. But yeah, thank you. I appreciate that. Yes, thank you. It's plus the 10, take away the 2. So my answer is 21. Thank you, Eve. Thank you, Pancake and KK. That was easier than I thought. Yeah, yeah. And what it is, a lot of it is just understanding, knowing the formula, knowing your partners. As long as you understand the partners, you can either add the 10 or take away the 10. So I don't have the minus ones. Oh, I hope you find relief. I, yeah, thank you. I appreciate that, Eve. I appreciate that. But yeah, knowing your pairs, right? You can either add the 10, which is what? Borrowing, or you can carry on, or you can trade in, or you can group and regroup. But in abacus world, we don't call any of that. We just call it adding a 10. We add a 10, or we add a 5. That's all we're doing. So we understand this. Are we okay? Okay, let's do one more. And what does that mean? Well, we're going to do is we kind of understand our adding of the 5. Now what we're going to do is we're going to Tetris our information. What does that mean? Well, when we look, we have a slight issue. I need another one. We're doing it. We're doing it. So the question is well, isn't adding 5 8 plus 5 and 5 plus 8, isn't that the same? And there was a parent that said that and asked me, and I'm like, yeah, no. It's very different. What makes it different? What makes it different is the add-in. It's this add-in. So the first thing we're going to do is exactly right, Eve. So then what we're going to do is we're going to add the 8. We add the 8, right, and we add the 5. What is the formula to add the 5? Add the 5 or add the 10. Well, there is no 5 when we make a 5, right? To make a 5, we don't have a 5. Yes, thank you, Pancake. It's plus the 10 minus the 5. So we're going to do 5 is equal to plus the 10 minus the 5. So we're going to add the 10 and minus the 5. So my final answer is 13, which we got. Not a problem. So now we're going to do this, right? We're going to do this. This is what we call, let's go through. Let's do it. So we add the 5. Is there enough? Yes, I'm going to add the 5. Now we need to add the 8. What is the formula to add the 8? What's the formula to add the 8? 8 is equal to, is equal to what? Yes, thank you. Thank you, user 060685. Minus the 2 plus the 10. Yes, minus the 2 plus the 10. Minus the 2 plus the 10. So I'm going to minus the 2 plus the 10. I'm going to add the 10 here. I'm going to take away the 2. Wait a minute. Yes, there you go, Pancake. I cannot take away the 2. What do? I have to minus the 5 plus the 3. Why? Now this is what we call a two-step equation. Minus the 5 plus the 3. So I want to minus the 5 plus the 3, and my final answer is 13. So this is the final concept we need to understand. We need to understand the two-step equation, and that's what it is. This is what we call a two-step equation. We don't Abacus world doesn't call it two-step, but in mainstream is what we call it. So what do we do? Because these two are connected. If there's not enough, we have to find another way. Now we can do is critical thinking. Oh yeah, we'll do some more. Thank you, Eve. Thank you for the support. I do appreciate that. So we were going to do another two-step, or are we going to do just a 10, right? Adding a 10 is so easy now. Why? Because now we get to the point where we're starting to critically think, what are we trying to do? So let's do another two-step. 49 plus, we'll do easy. We'll do 5, right? Thank you for the likes, Eve. So this is easy. Why is it easy? Because we've done 5 before. This is 49. We do 49. Now what are we going to do? We're going to add the 5. We're going to add the 5, right? We're going to add the 5 to the 9. We're going to add the 5 to the 9. This first number shocked me. That first number shocked me. But see, the thing is you take it one step at a time. So the first thing we're going to do is we're going to add the 5. How do you add the 5 to this? You cannot add a 5. What do we do? What do we do? Cannot add the 5. What is the formula to add the 5? Yes, thank you, Kay. So what we're going to do is add the 5 is equal to minus the 5 plus the 10. We can do that. We can do minus the 5 plus the 10. So let's minus the 5 first. I'm going to minus the 5. And then what do? I have to plus the 10. Remember what 10 is? 10 is 1, 0, 1, 0, 1, 0. I can't add a 1 here. How do I add a 1? How do you add a 1? Yes, Pancake. I would put down the 5 and I would take away the 4. Yes, Kay. Yes, Eve. So what's my final answer? My final answer is 54. 54. Now why? Because this turned into a two-step equation. Plus the 1 is equal to plus the 5 minus 4. But see, when you isolate each step, right? You isolate each step. It was way simpler than it looked. Yes, yes. So what you do, what with the, what helps is when you isolate each step. Don't go too far ahead. You need to look at each number and see what you can do. I think I'm finally getting it. Yeah, good, Eve. Good. So when we do it, we can do another one. We can do another one. Let's do another one. You know what? We, I mean, we could do another. Oh, you know what? We'll do 7, 26, 26 plus 25. Oh yeah, that's going to be a harder one. So does this, I'm sorry, let's see. So does this same concept apply as the numbers get larger? Yes, it does. It does. It scales. You just need to know those numbers. You can do, that's the secret, user. I don't know your name, but user 6856. That's the secret. The secret is you know how to add 5 and you know how to make it 10. It goes to it. You can do anything with it as long as you keep track. Yeah. I'm smart. Am I smart? Yeah, you are. Right? That's what was amazing when I discovered that. I thought so too. I thought so too. And I was like, what? That's crazy. So this is our number, 26. I'm going to add 20. I'm going to add the 6. Now what I'm going to do? I'm going to add 20. I'm going to add the 5. Whoa. How do we add the 5? We're going to add the 5 here. What is my formula to add the 5? What's my formula to add the 5? We know this. Yes. Thank you, Pancake. I'm going to say plus the 5 is equal to plus the 10, plus the 5, minus the 5, plus the 10. Can you say 6, 7? Hold on just a minute, post office sticker tower. Yeah. So the first thing I'm going to do is I'm going to minus the 5 plus the 10. So I'm going to minus the 5, and then I'm going to plus the 10. Guess what? I can't plus the 10. How do I do? What do I do? What do I do? Plus the 10. Remember, plus the 10 is 1 and a 0. Plus the 10. Yes. Plus the 5 minus the 4. And my final answer is 51. 51. Thank you, Eve. Thank you. Hawk. Yeah. Aura. If you're going to just continue to spam post office sticker tower, you can just move on. So, does that make sense? Hey, Terry. Welcome back. Okay. So, post office sticker tower. Wait, I'm confused. Okay, thank you. It makes so much sense. Okay. Okay. Eve, let we had 26. We added 2. Post office, when we add 2, we're adding 2 beads. 1, 2. 1, 2. These are the 2 beads I'm going to add. Okay? Now what we're doing is we're going to add this 5. We're adding a 5. The 5 will always be the top bead. Eve, we're adding the 5. We're adding the 5 here. Adding the 5 is what? Minus the 5 plus the 10. Minus the 5 plus the 10. So you add left to right. I do, yes. I believe we do. In abacus world, we do from left to right. I think it's just easier to go left to right as well. We do the same thing in multiplication. Okay. So Eve, you understand? Okay. Post office. 6, 7 looks like this. 6, 7. 5 looks like that. 6 looks like this. Anytime the beads are touching this horizontal bar is being counted. I get it. Oh, good, Eve. Good. I just jumped on the highway. Do. Post office, if you're not paying attention, you can leave. Because I'm telling you right now. I'm telling you how to read the abacus right now. I have 1. I have 2. Do you understand that? I have 3 and I have 4. Anytime the beads are touching this horizontal bar, they're being counted. Because they're being counted, this is 4. Does that make sense to you? When I have 5, no, because 6, 7, and doesn't equal to 100. That's not my question. Does this 4 make sense to you? Before you start jumping into adding, we need to make sure you understand how to read the abacus. So this is 4, and then this is 5. Does that make sense to you? So if I have this number, what number is that? Yes, 4 beads is 4. Thank you. Thank you. So then 5, right? And then 6. This is what 6 looks like. How do we get 6? Because we count from 5. 5, 6. 5 plus 1 is 6. 5 plus 2. No. 5 plus 2. This is not 2. Because you have to count the top bead. The top bead will always be 5. Thank you. 7. This is 8 and this is 9. So now when we look at it, we have 10. Good. So when we move the beads, we have 5 plus 2 is equal to 7. 5 plus 4 is equal to 9. Now what we were doing is we were adding and subtracting. So when we were doing 26, we added 20 and we added 6. Does that make sense? Okay, you need to stop. I'm going to move on. Okay, so Eve, that makes sense, 26. Okay, we can do another one if you want, another two-step equation. Are we ready for that? Okay, post office, you need to stop. I'm going to block you. Do another one. All right, cool. Let's do another one. So what we're going to do is, because I like the two-step one because then you can see what we're doing. So what are we doing? I should. Okay, we could do, oh, you know what? This is a nice one. This is a nice one. We could do 9999 plus 3. We could do that. 9999. We're going to add the 3. When we add the 3, what are we going to do? We're going to add the 3. What is our formula to add the 3? What's our formula to add the 3? Oh, not that one. Yes, good. But I have 5 already. Can you not start from the right? Why do you start when using the abacus? Why don't, oh, because I have this indicator. This is my ones indicator. Take away the 5. No, can't take away the 5. And then add the 2. um, Calvin, the reason why I start here is because I have my ones indicator. My ones indicator here, yeah, okay, good. This is my ones indicator. So my decimals, my tenths, and my hundredths. So that's why I do it here. That's why. So I'm going to add the 3. If I don't have enough beads to add the 3, guess what I do, right? If I can't add the 3, what do? I have another way to add the 3. There's another way to add the 3. Yes, plus the 10 minus the 7. So minus the 7 plus the 10. Yes, we could do that. We're going to minus the 7, and plus the 10. That's what we're going to do. So here, what we're going to do is, where's my, here it is. I'm going to minus the 7 and then plus the 10. I'm going to minus the 7. So I'm going to minus the 7. I'm going to plus the 10. When I add the 10, 0, 1, do I have enough beads to do that? No, I don't have enough beads to do that. I don't have enough beads to add the 1. How do I add the 1? How do I add the 1? I'm going to change it to this. How do I add the 1? Because now what we're doing is we're modifying it. Yes, thank you. Plus the 9 minus the 9 plus the 10. So we're going to minus the 9 and then plus the 10. Yes, minus the 9 plus the 10. So now what? We minus the 9. So what are we going to do? Can we do it? No, we can't. We can't plus the 10. So we got to minus the 9 and we're going to plus the 10. Can't do it. We got to do it again. Minus the 9 again and do it and plus the 10. Can we plus the 10 here? Yes, we can. So now we're done. So my final answer is 10002. Yes, exactly. You do it till you can't do it anymore. You find a way to do it until you're done with that task. Thank you. Yes, exactly. Right? Easy. Easy. Yes. 10,002. Yes, yes. Almost, Bible. This one here is the decimals. So we don't do, it'd be a, what you wrote would be a dot. So there would be 00, it would be looking like that. Where's my, so yeah, thank you, Kay. Thank you, Bible. Yep. So does that make sense? So what did we just do? This was what we call, this is no longer a two-step, but what we did is we Tetrised our way through. We Tetrised our information. We Tetrised our concepts that we understood. We have these concepts that we're teaching the kids. Now what the abacus does is we take it one step forward. Make sense? So when we do that, that's what we did. And so then this is why it's kind of fun. When teaching abacus to young children, how do they show their work? They don't. They have to follow what the teacher says, right? They can use the abacus to check themselves. Can you use the abacus to decide? To decide what? The abacus just tracks your number. It doesn't do anything else except track your number. You are calculating it. You are doing the calculations in your head. You are doing the critical thinking. You are doing the analysis of the numbers. The abacus is, there's no brain to the abacus. This just helps you put the numbers. 9. So, can you use the abacus to decide what? Oh, divide? Yes. Yes. You can use the abacus to divide. I remember when I started in grade 2, I didn't use it. Uh, yes, you can add, subtract, multiply, and divide. That was hilarious. Decide on what? Yes. So, are we ready for multiplication? Pancake, is this the only time you're teaching the abacus? No, I teach the abacus many, many, many times and all sorts of times. Yeah, ask the question. No? Eve's been trying to catch me. I never taught to divide or multiply. I will have to pause you too. Cool. Okay, I have to go. So I will have to continue learning tomorrow. Okay, Pancake, have a good night. See you later. I was never taught to divide or multiply. Mm. Let's add again. Okay, let's add again. So we could do you two say yeah. I'll try. Except for the trolls. I need my troll keeper. My troll keeper left somewhere. All right. I have to go. Yeah. See you later, Kate, and talk to you later. Yep. Catch me in my next live. I'll see you in my next live. Thank you, Yana. Thank you for the follow. Okay. So let's do another one. Let's do let's do 40 45 plus 6. We'll do that. Okay. Oh, no, you can't see that. There we go. 45 plus 6. Yeah. Okay, Kay. I'll see you next in my next live. So 45, we'll do 40, we do 5. Because we did 45, and then what are we going to do? We're going to add the 6. Hey, just random. Hey. So what we're going to do is we're going to add the 6. When we add the 6, right, we're going to be right here. When we add the 6, what is our formula? Our formula is what? Eve? I'm in suspense to learn to divide and multiply. Yes, thank you. So we're going to plus the 10, plus the 10 minus the 4. Yes, we're going to plus the 10 minus 4. But guess what? We can't minus the 4. What do? We cannot minus the 4. How do we do it? How do we minus the 4? Minus the 4 is what? Sorry. Don't. You're fine. You're fine, Eve. We're good. If Bible Dose doesn't like it, then Bible Dose can go somewhere else. That's fine. Yes, thank you, Yana. Minus the 4 plus the 10. Yes, thank you. Yes, Eve. It's minus the 5 plus the 1. So we're going to minus the 5 plus the 1. Good job, Yana. And so now what we're going to do is we're going to plus the 10. So we're going to go over here and we're going to plus the 10. We're going to plus the 10. How do you add the 1? Can we add the 1 here? Remember how to plus the 10? 1 and 0. 1 and 0. How do we add the 1 here? Yana, do you remember how to add the 1? Yes, thank you. So plus the 5 minus the 4. So my final answer is 51. Yes, thank you. Thank you, Bible Dose. 51. Does that make sense? So what did we just do? We did we did a one step here, and we did another step here. Does that make sense? So it can get complicated. You just have to track where your numbers are. How are we doing? All right? Thank you, Bible dose. Getting it. I think we can try to multiply. Okay, let's do multiplication. Oh, you know what? We're going to do. Uh, okay. So the first thing we're going to do in multiplications, we're going to understand that we don't memorize anything higher than 9 times 9. Just so you know. Just so you know. Yana, are you okay? Oh, I remember my teacher put a dot between the two on the left. And I was too little. How old were you when you were learning the abacus? And was it this kind of abacus? Or was it a different kind of abacus? Was it a two and five? Was it one of these? Or was it one of these? Hey Jazzy, I've been on the app. They're very fascinating and seems to learn. Yes, they are. It's quite interesting to learn. And it keeps your mind active. Bible, I was 8. Oh, same one. Okay, okay, okay. So that's very interesting. That's very interesting. Okay. Multiplication. So the first thing we're going to do is we're going to understand how to multiply. The question is 14 times that by 7. Notice that what we're going to do is we're going to do distributive property. Property. So what does that mean? That means that we're going to go one and then we're going to go another. That's how abacus does it. But the first thing we're going to do is understand how to find our location where we're going to put our answer. So we're going to count our digits: 1, 2, 3. Because we have 3, we're going to start here: 1, 2, 3. So what happens is my answer is going to be here. It's going to be right around here somewhere. So we kind of get a ballpark idea of what we're going to do. Are you a real teacher in school or do you have a different job and this is my free time? I'm I did have a job. I got laid off and now I'm trying to get this off the ground. That's what I'm trying to do. So, I've been doing this for a couple of months. But I've been teaching abacus for about 20 plus years. We have a learning center in Monterey Park. And that's more in person, but I'm trying to do this more on the internet. I'm in California right now. I'm in Monterey Park. So 1, 2, 3. We're gonna do 7 times what country? The United States of America. Thank you, Yana. Yes. 7 times 1 is equal to 7. 7 is a single digit. 7 is a single digit. So I go back one column and I add the 7. What's going to happen is I do that, right? And then what I'm going to do. Yes, you're right, Yana. Yes, exactly. It's exactly, and that's what distributive property is. That's what distributive property is. So 7 times 4 is equal to 24. 24, no, 28. 7 times 4 is 28. So I add my 2 and I add my 8. So my final answer is 98. Yeah, I'm in California. California, Los Angeles. Los Angeles, California. I'm in the United States of America. Yes, yes, Yana, you are absolutely right. So this answer is 98. That's the answer. Eve, did that make sense? No. Okay, that's okay. Let's do another one. Let's do another one. Okay, we'll do this one. 14 times that by 6. So the first thing we're going to do, right? The first thing we're going to do is we're going to count our digits. 1, 2, 3. 1, 2, 3. So our answer is going to be somewhere in the hundreds. Does that make sense? Oh, I see. Sorry, Bible. I didn't understand that. I assume everybody's in America because everybody's in America. Sorry, I apologize. You know, there's a few I know a person in Ghana that's teaching abacus. His name is Sir Patrick. Okay, so Eve, the first thing, so we know we're going to be here. Our answer is going to be here. So what we're going to do is we're going to do 1 times 6. 6 times 1 is equal to 6. 6 is a single digit. 6 is a single digit. So that means I have to go back one column. I'm in German. Oh, wow. I I apologize for assuming everybody's cuz it's late. It's like really late and I'm just surprised. It's 11:30 p.m. for me. It's almost midnight. What time is it in Germany and what time is it in South Africa? I apologize. I didn't. You know what it is? It's also because I had some spammers. I had some trolls, and so that kind of put me off a little bit. It's 8:30. Oh, that's early. I'm watching from Malaysia. Oh, oh my god. In the morning. Oh, okay. I just assumed. Yeah, okay. Cuz somebody was anyways. All right. Um Eve, does this make sense? Oh, sorry. So what we're going to do is we're going to make it look like this. We're going to make it a two digit. I am very ignorant of what time it is. I just woke up, Jazzy. So why are we going to make it two digit? Because we got to move it to one column. We got to move it to one column to the next column. It cannot sit here. That's just a rule. That's just a rule. That's just a rule that you're going to have to know. This is something you have to memorize. So when we look, we're going to put the 6 here. Every time we want to, yeah. So every time it's a single digit, you want to try to make it a double digit. Same time zone. Yeah. You guys, okay. I don't feel so bad that it's in the middle of the night. How about using tenths? So green equals 1. Yes, green, this is equal to 1. That's correct. Always? Yeah. Blue equals to 5. Yes, correct. Correct. So 10 times 60. No. 10 times 60 is different than 0.6. Yeah, see? That's you're in the same time zone as me. They all equal to 9. Yes. This is 9999999. These are all equals to 9. Yes, exactly. Exactly. Wow, you guys are catching on fast. So what we're going to do is we're going to do 6. Yeah. Yeah, Bible, yeah, it wouldn't work that it's not a 10 times 60 because it's reverse. So you know what? Just like what we were talking about in time, right? Like what time is it? It's 11:09, right? When you talk about the time, you have a 0 here. When you say it's 1 o'clock, it's 1 o'clock, it's 1:05. 1:05. Isn't that how we talk about it? Right? When we do things and they're all equal to 9. Why 6 on the 10th row? Why 6 on 10th? The reason why is because we started here. We counted our digits 1, 2, 3. 1, 2, 3. So when we look, yeah, the rule would be if it's a single digit, you go back one column. Single digit, go back one column. Go back. Go back. Yeah. If it's a single digit, you go back. Make it a double digit. Okay. Okay. Here we go. Here. We'll do this one for math reasons. Yeah. We want to make it a double digit. Yeah. That represents 60. Yes, 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 yes. So, yes. So Yes, I see what you're saying. I see what you're saying, Bible. Yes. So what we're doing is we're doing 60 times 6 and then we do 4 times 60. But see, the thing is we started here on the hundreds column. Because we started the hundreds column, we cannot keep it here. In abacus world, we don't do 10 times 60. What abacus world is, we do 1 times 6. That's what we do in abacus world. Yes. To make it a double digit. Yes. To represent 60. Yes. Yes. Okay, Yana. Yes. So what we're trying to do, if I take it like this, 1 times 6 is equal to 1 times 6 is equal to 6. 1 times 6 is equal to 6. We cannot keep it here. I'm sorry. We cannot keep it here. We have to move it. Yes, we have to move it to the next one over. We have to make it when you add the 0 to the right. Exactly. Yes. Okay, yeah. So you could say this, but then it gets really confusing if you scale it, if that makes sense. So let's continue on and I'll show you how difficult it can get. So we have our 6, 1, 2, 3, 6. I'm going to add the 6 here. And then my next one is 24. I add the 2, 24. I add 2, and then I add 4. Easy, right? Thank you, Mel. Hey, Mel, welcome back. Yes, 0, 6. Yes, thank you. So our final answer is 984. Right? Okay. So what's going to happen is let's let's make it more complicated. The reason why I don't do 10 times 60 is because the numbers can get bigger, right? So we do 4374 times that by 582. Now it gets really complicated. We are not going to say 500 times 4,000. What we're going to do is we're going to count our abacus. We're going to count our digits. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That's too much. Let's do that here. We're going to start here. This is my ones. I'm very nervous after seeing the number. We'll go slow. Let's see if I can do it. It's getting late for me. This will probably be my last question because it's almost midnight for me. All right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I'm going to start here. So that's where I'm going to be, right? And I'm going to show you why we do only the one digit. I'm going to use this one because it's easier. So now what we're going to do is we're going to go left to right. 5 times 4 is equal to 20, right? We are not going to say 500 times that by 4,000. We're not going to say that because it gets confusing really quick. But that's why we have the rules to help us understand. I'm going to add 20. I'm going to add 2. I'm going to have my 0. So I'm done with this, right? Now I go to here. 5 times 3 is 15. 5 times 3 is equal to 15. See how it's a double digit? So I had the 1, I had the 5. 5 times 7, 5 times 7 is 35. I had 5, I'm at 30, and at 5. Whoa. Yes, I keep going, right? Because I have to end up here. So 5 times 4, 5 times 4 is equal to 20. I had my 2, I had my 0. Now I'm done. I'm done with this one. Now what do I do? I count again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'm over here now. We go 8 times 4. 8 times 4 is 32. I add 30 and I add 2. Cannot plus 2. So I thank you, Bible. Yes, plus 2 here. Cannot plus 2. Plus the 10 minus the 8. 8 times 3. 8 times 3 is 24. Add 20, add 4. Can't add 4. Plus the 10 minus the 6. 8 times 7 is what? 8 times 7 is 56. Is that right? 56? 8 times 7 is 56. Add 50, add 6. 8 times 4 is 32 again. Add 3, add 2. So I'm done with my 8. I'm left with the 2. 2 times 4. I'm sorry, count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm over here. Whoa, I'm over here. So what are we going to do? Let me see if I can move it up. So 2 times 4 is 8. 8 is a single digit. I go back one column and I add 8. There's not enough. Plus 8 is equal to, or minus 8 is equal to what? Minus 8 is equal to minus the 10 plus the 2. So I minus the 10 and I plus the 2. 2 times 3 is equal to 6. 6 is a single digit. I go back one column and I take away the 6. No, I need to add. I'm doing subtraction. Sorry. I'm adding. I need to add it. Sorry. Plus the 8 is equal to plus the 10 minus the 2. Oh, I just messed it up. Plus the 10 minus the 2. Cannot minus the 2. So I need to minus 3. There we go. Sorry, I just went to division by accident. I just messed up my number. So 2 times 6 is, I added my 6. 2 times 4 is 14, plus the 1. Cannot add 1, plus the 1, plus the 4, and then plus the 8. I don't know if that's the right answer. I just messed it up. So what I'm trying to show you is we don't do it with the zeros. I'm very tired. I just switched to division by accident. All right. Whew. I don't know if that's the right answer. I'd have to do it again. It was too much stuff. Thank you for the follow, Bible. Uh, but just so you know, it is scalable. All right. My headache is starting to sit in. Is there any other questions other than me messing it up? Like it's a horrible mess up. I messed it up pretty bad. Oh, okay. Sorry. Back to here. Let's go back to something over there. There we go. uh, I don't know if I've lost anybody. Sorry. I apologize. I apologize. It is late. Anybody have any questions? Or do you want to continue doing multiplication? Okay. Uh, yeah. Yeah. So that, I'm sorry, that is why we don't do this. But we do this because it's more manageable. All right, because this is our multiplication facts. Hello, teacher Ermina. All right. Anybody have any questions? It's making sense. Okay, good. Even though I could royally mistaken everything, I somehow I don't know. I just started thinking about division. But yes, you can do division on the abacus. You can do division and you can do multiplication. So it's interesting. Bible, you did do multiplication on the abacus or no? I just need to get hang of it. Yeah, yeah, and that's the one thing. So I mean, oh, interesting. Yeah, I'm actually building out a book to do multiplication on the abacus. And then the questions are going to be very specific, and it will slowly bring you through the whole thing. Excuse me. Yeah. Yeah. So only adding and subtract. Oh, interesting. How big were your numbers when you added and subtracted? And how many lines? So, like, I know in abacus world we do 10 lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know mainstream math, 1, 2, 3. They go as high as 4, which is interesting. But it's very common to have like, and it's a lot about practice, but it all depends on what you're trying to do. Yeah. Excuse me. Okay. We use the abacus you're using. They cap the sums to fit. Oh, interesting. That's interesting. That's very interesting. You know, because my school, I've been teaching abacus for 20 years. We started with the 23 column one. And then and then just recently we started to use the 13 column one. The one before this one. Oh, interesting. Oh, interesting. The colorful one? This one. That's very interesting. Because this is only 7 columns. You can't do too much with it. I would, if wanted to, you 13 is actually a better um is versatile. 13 is more versatile because you can do multiplication and division. You can do bigger multiplication division on the 13 column one. But I think the 23 one is too much. I think 13 is a good number. 7 I think is too small. And that's a pity, because if you look, you can only go up to 10,000. So, yeah, that's too bad. But then again, it's like, I think the big reason why I would go to this one is for to do multiplication and division. That would be the reason why I go to 13 column one, because it's hard to do even like 3 digits times 4 digits. So even in doing 3, 4, 5 times that by 4, 5, 8, doing something like that is still too difficult to do it on this, because you do 6, 1, 2, 3, 4, 5. Oh yeah, if you follow the decimal, if you follow the dot indicator, you can't do more than 5. 1, 2, 3, 4, 5. This is already 6, so that's why I would recommend doing it on a 13 column one. But that's very interesting. Okay, it seems kind of, anybody else here? You guys okay? Any questions? Any other questions? Thank you, Bible. That's very interesting. I'm just reading all the comments. Okay. Yeah. Oh, hold on. Yeah. So I'm in the process of building out my other book, and so this one's about how to take away the friends. Then this is what you do, the minus ones. We were doing this a little bit earlier, and then I have like activities, so it's not going to be too boring. And then what I got to do is I usually make a what do you call I usually make a video out of this. I think my teacher knew that she wasn't on teaching me multiplication division. Really? That's too bad. It's fun to do multiplication and division. I don't know if she knew how to. That's also a thing too. This one's tic tac toe. So hence she didn't use the big. Oh, I see what you're saying. I see. Oh, that's interesting. The program that I teach, we teach the kids all the way to multiplication division. Is it because you did not want to advance to multiplication, or was it you got busy? So I know sometimes the kids get busy, and so they actually stop taking abacus. For us in America, it's more of an enrichment program. It's not part of the curriculum, and so a lot of people don't even understand the benefits of the abacus. And so that's what I've been trying to do, is I've been trying to show the benefits of the abacus, and how easy it is for the kids to understand. I don't know, I think it's more popular in South Africa than it is in America. I do follow a few abacus teachers that are mostly in Africa. So this is a little preview of my book. Yeah, it's not much of a preview if you only see the top part. but uh but yeah, I got to make some videos out of this cuz I have an online class. I created an online class just to make sure, um to try to get it out there. Yeah, and that's it. Okay, yeah, that's it. So this book is going to be available soon. Oh, excuse me. So, um, anybody have any questions? I don't know if Eve's still around. It is late. I think Jazzy still here. I don't know if Yana's here either. Okay. If there's no other questions, I am going to sign off. Any more questions? Okay. All right. Well, I'm going to head out. Thank you guys for joining. Thank you guys for attending, and have a good day, good evening, and good night to everybody. And I hope to see you in my next live. Oh, yeah. Okay. Have a good night, everybody. Thank you. My God.